Hello there, and welcome to the Sleepy Professor, where curiosity curls up beside comfort and the universe becomes a place not to solve, but to gently wander through. Tonight, I'd like to take you on a slow and quiet drift through the galaxy we call home, and then beyond it toward the enormous, humbling, and almost impossible shapes that fill the cosmic deep. You and I, right now, are sitting somewhere inside a glowing river of starlight called the Milky Way. We're surrounded by more stars than we could ever count, more worlds than we could ever visit, and more stories than we could ever tell. And yet, in the grand map of the universe, our home is only a small patch of brightness in an ocean so vast it barely registers as a glimmer. It's a tiny island of light in an endless sea of darkness and distance. Before we begin this long, slow journey, I wonder where you're listening from tonight. Is it quiet where you are? Perhaps there's the soft hum of a night lamp nearby, or maybe the stillness of a room that's finally settled down for the evening. Perhaps you're lying back with your eyes closed, letting your mind loosen its grip on the day, or maybe you're the kind who likes to picture things as they unfold, seeing the shapes in your imagination as words paint the universe around you. Wherever you are, and whatever time it happens to be for you right now, that's exactly where this story starts. Not out in the stars, not in some distant galaxy, but right here with you, in this moment, in this breath. Because every cosmic journey begins with a single observer looking up at the night and wondering what lies beyond. If you find these cosmic rambles a comforting way to fall asleep or just a pleasant way to slow down, I'd be grateful if you gave this a little like or maybe subscribe to join more of these calm explorations. It helps this space of quiet science reach others who might need a soft voice drifting through their own night. It helps us build a small community of cosmic wanderers, all drifting together through the same questions and the same wonder. Now, settle in. Let your shoulders drop. Take a slow breath and imagine this. Above you, far above the clouds and the thin blue line of our atmosphere, the Milky Way stretches across the night sky. It's a faint milky band that humankind has looked at for as long as we've had eyes to look up, for as long as we've wondered if there was something more beyond the horizon. To the naked eye, it's just a pale smear, a soft brushstroke across the darkness. But through the lens of science, through the precision of telescopes and the patience of astronomers, it's a spiral of hundreds of billions of suns. Every pinprick of light you see on a clear night is just one small beacon inside it, like a single lantern on a dark sea, and every one of those beacons is a star, perhaps with its own planets, perhaps with its own stories playing out in silence. When you see a photograph of it, the Milky Way often looks like a swirl painted on black velvet, its arms curling around a bright core. The images are stunning, full of colour and detail, rich with the glow of nebulae and the shadows of dust. But that's not how we see it from Earth. From inside, it's more like looking through the trees of a forest. The branches of stars stretch in every direction, and no matter where you turn, there's more light behind it. You can never step back far enough to see the whole picture, because you're always part of it. If you could step outside and look back, if you could somehow travel far enough away to see our galaxy as a whole, you'd see something with an elegance that borders on simplicity, a disk about 100,000 light-years across, rotating gently like a slow-spinning coin. Its spiral arms are rich with gas, dust, and star clusters that glimmer faintly against the dark. That's home, one galaxy among billions, orbiting quietly in a cosmic neighborhood that we call the local group. It's easy to think of it as enormous, and to us it absolutely is. Everything we have ever known, every person, every life, every story, every moment of joy and sorrow has unfolded in a tiny corner of one of those arms, a mere 25,000 light-years from the center. Our entire history, from the first spark of human consciousness to this very moment, has taken place on a tiny blue dot circling a single star in one quiet arm of the Milky Way. But if we lift our gaze just a little higher, if we stretch our imagination a little farther, we begin to see that our galaxy is not a giant at all. It's more like a middleweight, a standard model, a kind of average spiral that sits comfortably between the small and the colossal. It's the galactic equivalent of a medium-sized town, neither a village nor a metropolis, but something balanced and stable in between. You can picture it like this. Imagine the universe as an endless city at night. Every galaxy is a glowing window, a single lit room in an infinite apartment building. Some are small and faint, barely visible in the darkness. Others are vast and brilliant, blazing with the light of trillions of stars. The Milky Way is one of those steady, medium-bright windows, beautiful certainly, but not the biggest, not the most extravagant, not the one that draws every eye. Somewhere out there in that same endless city are structures so enormous that even light, which moves faster than anything else we know, takes millions of years just to cross them. Those are the giants of the universe. Galaxies that dwarf ours, galaxies with 10 times, even 100 times more stars. Galaxies so large that the Milky Way would fit inside them several times over with room to spare. Galaxies that contain not billions but trillions of suns, each one a furnace of nuclear fusion burning quietly in the dark. It's hard to think about that scale without the mind slipping a little. Numbers start to lose their meaning when they get that large. 100 billion stars feels abstract, like a number written in a textbook. 1 trillion stars feels almost fictional, like something invented for science fiction rather than discovered through science itself. Yet those are the kinds of numbers that define the biggest galaxies in existence, the cosmic titans that sit at the centers of galaxy clusters and dominate their surroundings with sheer gravitational presence. To compare ours with theirs is like comparing a glowing campfire with a city seen from orbit. Both are beautiful, both are made of the same light, both follow the same laws of physics, but they're living on vastly different scales. One is intimate and contained, the other sprawling and immense. And yet there's something strangely reassuring about that, because in a universe filled with extremes, with objects that defy the limits of size and brightness, our galaxy feels balanced. It's not too big to be chaotic, not too small to fade away. It's stable, star-forming, quietly turning for billions of years. It's the kind of galaxy where life had time to appear, where the long, slow unfolding of complexity was possible. Maybe that makes it ordinary in cosmic terms, but extraordinary in human ones. Maybe the most remarkable thing about the Milky Way isn't how large it is, but how perfectly suited it is for the emergence of observers like us. As we wander through this story together, we'll look at what makes a galaxy what it is, how ours compares to its neighbors, and what happens when you venture out to meet the giants, the cosmic cities that make our Milky Way seem like a quiet town on the edge of a vast metropolis. But we'll move slowly. The universe isn't in a rush, and neither are we. Between each idea, there's space to breathe, to let the mind settle, to imagine the distances and the light. Think of this as a slow flight outward. From home to horizon, we'll begin with the familiar, the spiral we call home, and gradually drift toward the edge of what we can know, where galaxies blur into clusters, and clusters melt into filaments of light stretched across the cosmos. You don't need to remember every number or name, just let them pass by like constellations seen from a train window, one after another, softly glowing, each one a small piece of the infinite puzzle. Out there somewhere are galaxies that make ours look like a single grain of dust in a beam of sunlight, galaxies that have swallowed others whole, that have grown in the centers of massive clusters until they became the anchor points of entire regions of space. They're strange to imagine because their scale no longer fits inside the normal frame of human thought. You could take every star in the Milky Way and repeat it hundreds of times and still they'd shine brighter, still they'd stretch farther. But even those vast structures are still small in comparison to the universe itself, which stretches far beyond anything we've seen, filled with light that has traveled for billions of years just to reach our telescopes. Some of that light left its source when the universe was still young, when galaxies were just beginning to take shape, when the first generation of stars was lighting up the darkness for the very first time. So tonight, as you rest, we'll take our time wandering among them. We'll look at what it means for a galaxy to be large, what kind of forces shape them, and what it says about our place that we live inside one that's perfectly ordinary by cosmic standards. We'll see how galaxies form, how they grow through mergers and collisions, and how they sometimes combine, merging into new shapes that continue to spin and shine for billions of years to come. The universe has a rhythm of its own, slow, patient, unhurried, like the turning of seasons or the drift of continents. Galaxies are its quiet dancers, moving to a beat that stretches across time, a rhythm measured not in seconds or minutes, but in millions and billions of years. As we drift from thought to thought, you might find your own rhythm slowing to match it, your breathing deepening, your awareness softening. That's all right. That's what this space is for. The universe can wait for your thoughts to catch up. There's no deadline, no schedule, no rush. When we talk about the Milky Way, we're not really talking about a thing we can ever see in its entirety. We're inside it, wrapped up in its glow, looking outward through layer upon layer of starlight and dust. Every direction we turn, we're staring through thousands of light years of stars, each one part of an immense pattern we can't step back far enough to view. We're like ants walking across a painting, able to see the brushstrokes up close but never the full image. The Milky Way is like a city you've lived in all your life, but have only ever seen from street level. You can sense its structure, the long avenues of stars, the bustling core where things are crowded and bright, the quieter outskirts where the light fades and the darkness begins. But you'll never see the whole skyline all at once, never stand far enough away to take it all in with a single glance. Astronomers have spent decades piecing that skyline together, not through a single image, but through evidence, through data collected from radio waves, infrared maps, and careful calculations. The shape that emerges from all that information is a spiral, not a perfect one, more like a living thing with arms that twist and drift slightly unevenly, as if sculpted by time and motion, rather than drawn by a ruler with geometric precision. 4 major arms, they say, along with smaller spurs and bridges that link them, each filled with clouds of gas and dust, and clusters of newborn stars glowing brightly in the infrared. The sun, and therefore we, are part of a small spur between 2 of those main arms, a quiet suburb far from the bright, restless center. It's a peaceful location, far enough from the chaos to remain stable, close enough to the action to see the beauty of the spiral's structure. If you could rise above it all and look down, the Milky Way would stretch roughly 100,000 light-years across. That's a number we can say easily, but can't really feel. 1 light-year is about 9.12 trillion kilometers, an almost incomprehensible distance on its own. So 100,000 of them means the Milky Way spans nearly a quintillion kilometers from one edge to the other. If you tried to count to a quintillion, 1 number per second, it would take you longer than the current age of the universe. It rotates too, completing 1 slow turn every 230 million years or so. In the time since the dinosaurs first appeared on Earth, the Sun has made only a single lap around the galaxy. That means every time the solar system completes 1 orbit, entire epochs rise and fall on Earth. Continents shift, species evolve, mountains erode, oceans form and vanish. And through it all, the Milky Way continues its patient rotation, indifferent to the dramas playing out on our tiny world. Right now, as you listen, we're drifting at about 220 kilometers per second along that orbit. That's more than 500,000 miles per hour, faster than anything we've ever built. And yet, everything around us feels perfectly still. The stars don't seem to move. The sky doesn't blur. We glide through space in perfect silence, carried along by forces too vast to feel. The heart of the Milky Way is a place we can't see directly because it's shrouded by dense clouds of interstellar dust. Visible light can't penetrate those clouds, so our view is blocked, like trying to see through a thick fog. But hidden in that darkness is a region of intense energy known as Sagittarius A star, a supermassive black hole about 4 million times the mass of our Sun. It's not the kind of monster that devours everything nearby in a single gulp. The way black holes are often portrayed in movies, it's relatively calm, quietly feeding on occasional gas clouds that wander too close. Most of the time, it sits in silence, a gravitational anchor holding the galaxy together. Around it, stars orbit at dizzying speeds, some completing their loops in just a few years. These stars have allowed astronomers to measure the black hole's mass precisely, confirming that it's the gravitational anchor of the galaxy, the invisible weight at the center of everything. Surrounding that invisible center is a bulge, a thick, crowded region of older stars that glows in golden light. These are ancient stars formed billions of years ago when the galaxy was young. They're cooler and redder than the bright blue stars found in the spiral arms, and they pack together so tightly that the night sky there would be ablaze with light. Beyond that, the spiral arms sweep outward, each one a blend of ages, a mixture of old stars and young clusters. The arms aren't fixed structures like the arms of a windmill, they're more like traffic patterns, regions where stars and gas bunch up due to waves of density moving through the disk. New stars form within these waves, lighting them up with their brilliant blue glow, then drift away, leaving behind faint traces that slowly fade as the stars age and cool. The arms are like cosmic rivers, always changing, always flowing, never quite the same from one moment to the next. Though that moment might last millions of years, stars enter the arms, brighten, then leave, carried along by their own momentum and the galaxy's rotation. If you picture the Milky Way as a glowing disk, there's also a faint spherical halo surrounding it. This halo contains ancient stars, globular clusters, tightly packed balls of hundreds of thousands of stars, and a great deal of invisible dark matter. That dark matter, though unseen, makes up most of the galaxy's mass, shaping its motion and holding it together like invisible scaffolding. Without it, the stars in the outer regions would be moving too fast for gravity to hold them. They'd simply fly away into the void, scattering into the darkness. Dark matter, whatever it is, acts like a silent framework, giving the galaxy its structure, unseen but essential, the hidden architecture that makes everything possible. From our position within one of the spiral arms, about halfway between the center and the edge, the night sky appears rich and crowded, at least when we can see it clearly. If you've ever looked up on a dark, clear night far from city lights and seen that faint white band crossing the heavens, you've glimpsed the Milky Way from the inside. What you're seeing is the combined glow of hundreds of millions of distant stars, their light blurred together by distance into a soft, milky glow. And even then, you're seeing only a small slice, just a few thousand light-years deep before dust blocks your view and the light fades into darkness. If you could see the rest, if your eyes could penetrate the dust and detect all wavelengths of light, it would wrap around the entire sky like a soft, endless ring, a sphere of starlight enclosing you completely. It's humbling to think that our solar system is just one among hundreds of billions inside this vast structure. Some estimates suggest there might be 100 to 400 billion stars in the Milky Way, and likely even more planets, perhaps trillions. Among them, billions could be roughly Earth-sized, orbiting in conditions where liquid water might exist, where the temperature is just right for chemistry to become complex, for molecules to organize, for life to begin. Somewhere out there, other worlds may circle their suns, perhaps with their own versions of night skies, their own quiet observers wondering if they're alone. looking up at their own Milky Way and asking the same questions we ask. In that sense, our galaxy isn't just a structure of stars, it's a potential cradle of countless unknown lives, a vast garden where the seeds of complexity may have taken root in ways we can't yet imagine. When astronomers measure the light from the Milky Way and compare it to other galaxies, they find it's a typical example of a spiral galaxy. It's not especially large compared to others, nor particularly small. Its diameter, its star count, its rotation speed, all fall near the middle of the galactic range. It's neither a giant nor a dwarf, but comfortably average, sitting right in the middle of the distribution. There's comfort in that ordinariness. It means our home is stable, balanced, not too violent or chaotic. Some galaxies burn too brightly, forming stars at a furious pace and then exhausting their gas quickly, flaring up and fading like fireworks. Others are quiet and dim, their star-forming days long over, their light the fading glow of ancient suns. The Milky Way sits in between, forming a few new stars every year, enough to keep it alive and glowing, but not enough to tear itself apart or burn out too quickly. This balance is what makes it special, not in cosmic terms, but in practical ones. It's the kind of galaxy where planets can form, where solar systems can remain stable for billions of years, where life has time to evolve from single cells to complex organisms capable of looking up and wondering about their place in the universe. Our galaxy is surrounded by smaller companions, faint dwarf galaxies that orbit it like satellites. The two most prominent are the Large and Small Magellanic Clouds, visible from the southern hemisphere as faint misty patches of light near the Milky Way's edge. They're beautiful in their own right, irregular galaxies rich with star-forming regions and glowing nebulae. Others are so faint that they were only found in the past 2 decades, hidden in the darkness, their light barely distinguishable from the background sky. The Large Magellanic Cloud, or LMC, is the largest of these companions, spanning about 14,000 light-years. It's an irregular galaxy, distorted by our gravity and by its own smaller partner, the Small Magellanic Cloud, or SMC. Together, they orbit the Milky Way, trailing long streams of gas known as the Magellanic Stream. This stream stretches across the sky, hundreds of thousands of light-years long, wrapping around the Milky Way like a faint ribbon of hydrogen pulled from the clouds by tidal forces. Eventually, this material will fall into our galaxy, feeding new star formation, becoming part of the next generation of suns and planets. It's a quiet act of galactic recycling that has been happening for billions of years and will continue for billions more. Beyond these bright companions lie numerous dwarf spheroidal galaxies, small, faint and diffuse, containing only a few million stars each. The Sculptor, Fornax, Draco and Ursa Minor dwarfs are examples, each one a tiny galaxy in its own right. They orbit far from the Milky Way's disk like scattered embers around a campfire, slowly circling the main mass, bound by gravity but maintaining their own identities. Most of them are dominated by dark matter. Their visible stars are just a trace of their total content, a small glowing core within a much larger invisible halo. They're fragile things, easily disrupted by tidal forces. Some are already being torn apart, leaving behind streams of stars that stretch through our halo like faint ribbons of light. The Sagittarius dwarf galaxy, for instance, is currently in the process of merging with us. Its stars form long arcs across the sky, traces of a galaxy that once was whole but is now being pulled apart by the Milky Way's gravity. In time, those stars will blend into our halo, their origin forgotten, absorbed into the greater whole. We tend to imagine galaxies as isolated, floating alone in the void like islands in an endless ocean. But the Milky Way, like most galaxies, is part of a community, a small family of galaxies bound together by gravity. Around 30 galaxies make up what we call the local group. a small cluster of cosmic neighbors held together in a loose gravitational dance. The Milky Way and the Andromeda Galaxy are the two largest members, like twin anchors holding the group in place. Between them lie smaller galaxies, each with its own shape, history, and motion. Some are bright enough to be seen with a small telescope. Others are so faint that only deep surveys reveal them, their light almost lost in the darkness. The stars we see overhead are all part of the Milky Way's disk, all members of our home galaxy. But if you could step back far enough, you'd see that disks set against the larger structure of the universe, clusters of galaxies connected by filaments of dark matter and gas, forming a web that spans billions of light years. Our galaxy is just one node in that web, glowing quietly amid a network of cosmic light, part of a pattern so vast it challenges comprehension. From where we sit, we can study only parts of it directly. Dust and gas block much of the visible light, so astronomers use other wavelengths, infrared, radio, and X-rays, to peer through the obscuring layers and see what lies beyond. Radio telescopes can map the distribution of hydrogen gas, tracing the spiral arms and revealing regions where new stars are about to be born. Infrared observations can see through the dust to reveal stars in the center, penetrating the veil that blocks visible light. X-rays show regions of high energy, where black holes and neutron stars release bursts of radiation, marking places where matter is being torn apart by gravity. Together, these different views combine like layers of a painting, each one adding detail and depth, revealing a galaxy alive with activity. It's easy to think of the Milky Way as static, as though it's been this way forever and will always remain the same. But in cosmic terms, it's a work in progress, a dynamic system constantly evolving. Its oldest stars, found in globular clusters, are more than 12 billion years old, nearly as old as the universe itself. Those stars formed when the galaxy was still taking shape, emerging from smaller proto-galaxies in the early universe, when the cosmos was hotter and denser, and the first structures were beginning to coalesce. Over time, the Milky Way gathered more gas, built its spiral disk, and began the long rhythmic process of star birth and death that continues today. Every star you see in the night sky is part of that cycle. Each one was born from clouds of hydrogen and helium that collapsed under gravity, igniting fusion in their cores and beginning to shine. Many will eventually die in brilliant supernova explosions, scattering heavy elements, carbon, oxygen, iron into space. Those elements mix with new clouds, forming new generations of stars and planets, each one slightly richer in the building blocks of complexity. In that way, everything you see, including yourself, is made of material forged inside earlier generations of stars. The calcium in your bones, the iron in your blood, the oxygen you breathe, all came from stars that lived and died long before the sun existed. The Milky Way is not just our home, it's our origin story written across the sky, a history book whose pages are stars and whose chapters span billions of years. Even though we can't leave it, not yet, we've begun to map it from within. Space probes and telescopes have given us a three-dimensional sense of where we are, like cartographers mapping a continent from the inside. The Gaia spacecraft, launched by the European Space Agency, has measured the positions and motions of over 1 billion stars, creating the most detailed map of the Milky Way ever made. From that data, scientists can trace how the galaxy moves, where stars were born, and how they drift over time. It's like watching the slow breathing of an immense luminous organism, seeing the rise and fall of stellar nurseries, the migration of star clusters, the slow churn of the galactic disk. And while it feels like we're at the center of our own perspective, we're not at the center of the galaxy. We're out on one of the arms, about halfway out from the core, in a region that astronomers sometimes call the Orion Arm or Orion Spur. It's a quiet place, not too crowded, not too sparse, the perfect environment for a stable solar system to evolve without constant gravitational disturbances. If we were closer to the center, the sky might blaze with the light of millions of nearby stars. Beautiful, certainly, but chaotic, with close encounters and intense radiation making stable planetary systems difficult to maintain. Out here in the suburbs, the nights are dark enough for life to unfold in relative calm, for planets to orbit peacefully, for evolution to take its slow, patient course. Our galaxy's beauty lies partly in that balance, active but not violent, luminous but not blinding, grand but not overwhelming. Its spiral structure is both delicate and enduring, a reminder that even in the vastness of space, order can emerge from chaos. Gravity, gas, and time work together to weave a pattern that lasts billions of years, a structure that's both ancient and alive, and we happen to be living inside it, a tiny part of its story, looking up and wondering, asking questions, seeking to understand our place in the cosmic dance. The Milky Way is our home, our origin, and our teacher. It shows us that we're part of something far larger than ourselves, and that even in our smallness, we have the capacity to understand the immense. We've wandered across the Milky Way, our luminous home, and now it's time to lift our gaze even higher. Out there, beyond the calm spiral of our galaxy, the universe holds giants so vast, they make our Milky Way seem like a quiet village on the outskirts of a metropolis. These are the largest galaxies in existence, enormous, ancient systems of stars and dark matter that have grown over billions of years through cosmic collisions and mergers. Imagine the Milky Way stretching its arms across 100,000 light-years. Now imagine galaxies so large they span several million light-years from end to end. The most extraordinary of them all is IC 1101, a supergiant elliptical galaxy that sits at the center of a distant galaxy cluster known as Abell 2029. IC 1101 spans roughly 5.5 to 6 million light-years across, about 60 times wider than the Milky Way. If you placed it where our galaxy is, it would completely engulf both the Milky Way and the Andromeda Galaxy, swallowing everything within 2.5 million light-years, including the space between them. EC 1101 contains an estimated 100 trillion stars, most of them ancient and red, long past their vigorous youth. New stars form rarely there. The galaxy is old, calm and vast, glowing like a fading ember rather than a blazing fire. Yet in its heart lies an enormous supermassive black hole, the largest ever detected, weighing perhaps 40 billion times the mass of our Sun. Its gravitational influence and immense radiation likely shaped the vast elliptical halo of the galaxy itself. While IC 1101 reigns supreme in the stellar sense, another contender for the title of largest comes from a different kind of measure: radio galaxies. Some galaxies produce immense jets of energy from their central black holes, sending streams of charged particles racing through space. The giant radio galaxy Alcyonius, discovered in 2022, stretches an unimaginable 16 million light-years across. That's over 150 times the width of our Milky Way. The visible stars of Alcyonius are far smaller and concentrated near the center, but its enormous radio lobes make it the largest galactic structure we've ever identified. Compared to these titans, our Milky Way feels calm and moderate. Our neighbor Andromeda is almost twice our size at 220,000 light-years across, and contains roughly 1 trillion stars, likely the largest galaxy in our local group. The Virgo supercluster's M87, famous for its photographed black hole, spans 980,000 light-years and shoots out colossal jets of plasma that shine brightly in radio wavelengths. Another heavyweight, NGC 4889 in the Coma cluster, measures about 1.3 million light-years, its stars swirling around a central black hole nearly as large as that of IC 1101. Most of these supergiant galaxies share one thing in common. They are elliptical, not spiral. They lack the sweeping arms and rich dust lanes of the Milky Way. Instead, they are smooth, rounded, and immense. Billions of aging suns moving in random paths, lacking the order of a disk, shaped instead by countless galactic mergers over time. These are the galactic cities of the cosmos, dense hubs of gravity and history, born from the collisions of smaller galaxies that came before. The largest spiral known, UGC 2885, spans an astonishing 830,000 light-years, making it more than 8 times the breadth of our Milky Way. Some call it the Godzilla Galaxy, a star-filled behemoth still maintaining its spiral form, a rare feat for a galaxy of such mass. Its sheer size challenges our understanding of what spiral galaxies can become before losing their structure to chaos. When we put all these together, the orderly spirals, the sprawling ellipticals, the colossal radio lobes stretching millions of light-years, we begin to see just how diverse and dynamic the universe truly is. The Milky Way is not insignificant. It's simply average on a cosmic scale, balanced and well-behaved, a structure where complexity could thrive. It is perhaps the very ordinariness of our galaxy that allowed beings like us to arise, observe, and understand. So as we drift farther into imagination, picture yourself suspended in the quiet between galaxies. Around you glow cosmic cities of impossible size, IC 1101 shimmering softly across 6 million light-years, Alcyoneus whispering its radio signal across 15 million, Andromeda waiting patiently for its distant dance with the Milky Way. Each one is a world of worlds, a chapter in the long story of the universe's growth and transformation. And somewhere halfway down one of the Milky Way's gentle spiral arms, there's a small star with a pale blue world orbiting it. A world that looks back at all this grandeur and feels both humbled and at peace. The universe does not brag about its scale. It simply exists, vast, ancient, and quietly unfolding. And in that quiet, our curiosity becomes its echo. Let's drift a little farther into the deep cosmic waters. We've seen galaxies like IC 1101, massive giants of light spanning millions of light years. But the truth is, the universe never settles. New discoveries keep rewriting what largest truly means. Some of the most recent contenders for the title aren't just larger in size, they stretch across definitions. One of them is ESO 383 76, a colossal elliptical galaxy in the Centaurus constellation. It extends an estimated 1.76 million light-years, making it measurably larger than the famous IC 1101. When considering its visible diameter, this enormous galaxy sits as the heart of the Abell 3571 cluster, an ancient collection of galaxies bound by gravity and dark matter. Another heavyweight, ESO 248 6, sprawls across about 1.73 million light-years and resides in the Eridanus constellation. Like ESO 383 76, it's a CD-type elliptical galaxy, meaning it sits at the center of a rich cluster and has absorbed countless smaller galaxies over time. These vast shapes are the universe's ultimate mergers, once vibrant spirals consumed and smoothed into featureless ellipses through billions of years of gravitational encounters. And then there's NGC 6872, sometimes called the Condor Galaxy. It's the largest known spiral galaxy, stretching an astonishing 718,000 light-years from tip to tip of its majestic arms. To put that in perspective, if our Milky Way were a bright dinner plate, NGC 6872 would be a shining disk nearly 7 times as wide. It shows that even ordered spirals, though rare at great sizes, can reach extraordinary spans without collapsing into the irregular chaos of a merger. The ASCAP J0107 2347 galaxy takes another approach to enormity. Detected through radio waves, it spans a breathtaking 12.4 million light-years end-to-end, not because of its stars, but because of the colossal radio lobes expelled from its active core. These lobes, formed by colossal jets of charged particles launched from a supermassive black hole, make it the largest radio galaxy ever found. Compared to these, our Milky Way feels modest, about 87,000 to 100,000 light-years wide, with up to 400 billion stars. It's not among the giants, but it's also not a dwarf. It sits at the cosmic sweet spot where order and life can persist. Its spiral shape, balanced between structure and motion, is rare among galaxies its age. Most large systems have long since turned elliptical, their star-forming gas used up by ancient collisions. Think of it like this. If you placed the Milky Way next to these cosmic leviathans, it would be a pearl beside a planet, small but gleaming, intricate in design, and full of vitality. The giants may win in scale, but our galaxy wins in stability, the kind of quiet where life can bloom and consciousness can rise to look back at the stars. The farther astronomers peer into the universe, the more enormous these cosmic cities appear. Some grow by shattering and consuming smaller galaxies. Others expand through slow gravitational tides, gathering gas over eons until they swell into new forms. Galaxies are not timeless sculptures, they're living systems, shimmering snapshots in an eternal process of creation and transformation. So as we float here, caught between imagination and infinity, think of the Milky Way not as small, but as perfectly sized for possibility. The giants beyond remind us how grand the universe can be, but this beautiful middle-sized swirl of starlight we call home, that is where the cosmos chose to watch itself awake. Let's continue our slow drift through the cosmos, past the quiet splendor of our Milky Way, and into even grander realms where the universe reaches its most magnificent scales. As vast as galaxies like our C1101 or ASO 383 to 76 may seem, they are merely individual rooms in far larger cosmic mansions. The galaxy clusters, superclusters, and vast webs of light that thread through the fabric of space. Imagine this. The Milky Way is a single glowing grain in the night. Now picture hundreds, even thousands of such galaxies clustered together, each orbiting the shared gravity of a massive concentration of dark matter. These are galaxy clusters, the largest gravitationally bound structures in the universe. Every one of them is a cosmic city made up of galaxies, gas, and invisible dark matter, intertwined in a dance that has lasted billions of years. The Virgo cluster, our closest major neighbor, contains about 1,500 galaxies and spans roughly 50 million light-years. Our Milky Way, along with Andromeda and their smaller companions, drifts along the edge of Virgo's vast gravitational field, slowly being drawn toward it. But the Virgo cluster is merely a modest district in a much greater assembly. The Virgo supercluster, a sprawling region of space that encompasses over 100 galaxy clusters, like Virgo itself, stretching across 110 million light-years. And even that is just one filament of an interwoven cosmic structure that astronomers have now begun to map in stunning detail. Using powerful telescopes like the Dark Energy Camera in Chile and the James Webb Space Telescope, scientists have charted tens of thousands of clusters and hundreds of millions of galaxies. These maps show something extraordinary. The universe is not arranged randomly, but forms an intricate web, a network of luminous threads and vast voids, regions almost completely empty of matter. It's called the cosmic web, and it stretches for billions of light-years in every direction. Recent discoveries have revealed that even this web contains titanic features. In 2025, scientists announced the detection of the largest cosmic superstructure ever reliably measured, a network of 68 galaxy clusters stitched together by gravity, spanning a phenomenal 1.4 billion light-years. This immense formation, identified using X-ray data from the AROSAT satellite, breaks previous records like the Sloan Great Wall, a structure once thought to define the upper limits of cosmic scale at 1.1 billion light-years. Think about that distance. Light, the fastest thing in existence, would take 1.4 billion years to travel from one end of that structure to the other. When that light began its journey, the first multicellular life was only beginning to evolve on Earth. The scale is so vast, it humbles even our imagination. Galaxies, each containing hundreds of billions of stars, forming endless chains of light that curve through the darkness like the scaffolding of the universe itself. But perhaps what's even more astonishing is how these structures teach us about the hidden ingredients of the cosmos: dark matter and dark energy. Without them, these enormous webs could never have formed or stayed bound together. Observations from projects like the Dark Energy Survey show that about 85% of the mass in galaxy clusters is invisible. We can't see it, but we feel its pull shaping space-time, anchoring galaxies in immense halos of unseen substance. Meanwhile, dark energy, the mysterious force driving the universe's accelerated expansion, works in opposition. It stretches space, pushing galaxies apart faster and faster. In the balance between gravity and expansion, the grand web of galaxies grows slowly thinner, its connections fading over billions of years. Someday, perhaps trillions of years from now, even the great superclusters could drift apart, isolated islands of light in an ever-expanding cosmic ocean. Yet, right now, we live in a universe where those connections still hold. Our Milky Way, drifting along the cosmic streams of the Laniakea supercluster, is part of an intricate gravitational pattern stretching over 500 million light-years, a web of light and shadow whose scale defies imagination. It's estimated that across the observable universe, there may be 2 trillion galaxies, each one with its own suns, planets, and unknown worlds. Projects like Cosmos Web, which recently mapped nearly 800,000 galaxies with the James Webb Space Telescope, have given us a glimpse of this cosmic architecture with unprecedented clarity. These maps reveal not just distant galaxies but the early history of the universe itself, showing us what space looked like only a few 100 million years after the Big Bang. Think of that. Through telescopes, we're looking backward in time, watching galaxies being born. Their faint light, stretched by the expanding universe, travels for over 13 billion years before touching our eyes. The image we see tonight is the reflection of an era when time itself was young. And within that cosmic ocean, our Milky Way, this beautiful balanced spiral, remains something special. Small compared to the colossal radio galaxies, yes, and modest beside the superclusters, but precisely in that middle ground where complexity flourishes. It's the kind of galaxy that allows stability, that allows stars to live long enough for planets to form, and for life to wonder where it came from. So, as you rest beneath the night's quiet ceiling, know this: the Milky Way may not be the largest or the brightest, but it is part of the grandest design ever made. Every star you see is one stitch in a tapestry that stretches across billions of light years, and every breath you take is time and matter made conscious of the infinite. When you look out at that faint milky river in the sky, you are not just looking at our galaxy, you are looking into the universe recognizing itself. Let's float even farther into the cosmic deep. We've looked at galaxies, galaxy clusters and superclusters. Immense as they are, they're still only individual threads in a far grander cosmic design. Beyond even the superclusters, the universe forms vast cosmic megastructures, the largest patterns ever discovered. These are the walls, arcs and filaments of the cosmic web. where clusters braid together like luminous rivers of galaxies spanning billions of light years. One of the most staggering discoveries in recent years is a new superstructure called Quipul, named after the ancient Incan system of knots used for recording numbers. This cosmic Quipul is not just large, it's colossal beyond imagining, stretching 1.3 billion light-years across. It's made up of galaxies gathered into clusters, clusters grouped into superclusters, and superclusters joined together in a filament so long it defies ordinary comprehension. Picture a single thread of light weaving through space, looping and branching, containing nearly 200 quadrillion times the mass of the Sun, a number so immense it loses meaning when you try to visualize it. To put it in perspective, if the Milky Way was a glowing marble, the Quipul structure would be a chain of those marbles, stretching across a volume that would take light 1.3 billion years to cross. And it's not empty in between. It's filled with galaxies, gas, dark matter, and ancient cosmic radiation tracing the blueprint of how the universe came to be. Just this year, scientists at the Max Planck Institute confirmed another equally impressive feature, a 1.4 billion light-year network of 68 galaxy clusters forming the largest measured structure in the nearby universe. It's made mostly of dark matter, invisible yet holding together enormous walls of galaxies scattered across the sky. The team estimates its mass to be 240 quadrillion solar masses, confirming that even the space near our cosmic neighborhood contains formations beyond all previous expectations. When astronomers map these structures, they find that they are not random or chaotic. They appear to form along filaments, long, narrow streams of galaxies running through the voids of space. The voids themselves are utterly dark, almost empty except for a trickle of gas and dark matter. The contrast is breathtaking. Bright walls of light bordering infinite cosmic hollows. The result resembles a living organism spread across the universe. Filaments like veins, clusters like organs, voids like vast lungs of nothingness, breathing space itself. Among these wonders is the legendary Hercules Corona Borealis Great Wall, estimated to span 10 billion light-years, discovered through patterns in gamma-ray bursts. It may not even fit within our current cosmological models, since structures that large challenge the cosmological principle. The idea that the universe should look roughly the same everywhere on the largest scales, whether it's a true physical structure or an artifact of observation, is still debated, but its discovery shows that cosmic enormity still has no ceiling. Other giants, like the giant GRB ring at 5.6 billion light-years, or the huge large quasar group, LQG, stretching over 4 billion light-years, reveal that the universe's architecture is intricate, ancient, and precise. Even the giant arc, 3.3 billion light-years long, bends like a graceful curve across deep space, composed of countless galaxies strung together like cosmic beads. All of this, the Quipul, the Great Walls, the LQGs, are snapshots of the universe's structure, frozen in light, that has traveled for billions of years to reach us. What we see is not how the universe is now, but how it was. These structures may no longer exist in the same form. Some could have evolved, merged, or stretched apart under cosmic expansion. It's humbling to think that even these enormous filaments, these rivers of matter longer than imagination, were seeded by tiny quantum fluctuations in the first fractions of a second after the Big Bang. In that primal moment, density ripples no larger than an atom began expanding, and after nearly 14 billion years, those ripples became galaxies, clusters, and entire walls of light. And where does our Milky Way fit in this unimaginable scale? It's part of the Laniakea supercluster, a region about 520 million light-years wide, which itself is part of the Pisces Cetus supercluster complex, extending roughly 1 billion light-years. So even our cosmic address is nested inside larger layers. the Milky Way inside Laniakea, which sits inside Pisces, Cetus, which is woven into one of the filaments of the cosmic web. It's like living in one room of a vast city inside a continent that stretches across the stars. The more we learn, the more the universe feels, both impossibly grand and beautifully connected. Every star, every atom, every breath of light belongs to this same network that stretches from the smallest hydrogen cloud to the largest cosmic arc. The Milky Way may be an average spiral galaxy, but it spins within one of the most extraordinary structures nature has ever assembled, the universe itself, a living, luminous sculpture woven of light, time, and gravity. And so, as you listen, wherever you are, however far from a dark night sky, know that you are already part of it. The atoms in your body once drifted among those same galaxies, shaped by the same forces, scattered by the same stars. Every glance upward, every whisper of curiosity, is the universe remembering itself. Let's travel even further outward, beyond galaxies, superclusters, and even the filaments that connect them to the cosmic scaffolding that holds everything together. At this scale, the universe becomes something both incomprehensibly vast and unexpectedly structured. Recent discoveries have revealed cosmic shapes so large that they challenge the boundaries of the cosmological principle, the idea that, on the grandest scales, the universe should look roughly uniform in every direction. Among these breathtaking findings, astronomers recently announced the identification of a structure called Quipu, now officially recognized as the largest known object in the universe. Named after the ancient Incan knot system used to record numbers, this immense superstructure mirrors that very idea, an intricate, interconnected series of cosmic knots tied together by gravity across 1.3 billion light-years. To travel across it, even light, the fastest thing in existence, would take longer than Earth's entire geological history, crossing a cosmic river of galaxies arranged in vast filaments and clusters that weave together into a luminous web. Quipu's scale is staggering. Scientists estimate it holds over 200 quadrillion solar masses, composed of hundreds of galaxy clusters, each containing trillions of stars. And just like its namesake from Andean civilization, a cord woven with branching threads, Quipu is shaped not as a single clump, but as a stunningly long filament, with delicate threads of galaxies extending outward into multiple smaller structures. It's a galactic road stretching through dark space, glowing faintly with the collective light of uncountable suns. Perhaps most fascinating is how this discovery fits into the broader cosmic puzzle. Quipu doesn't stand alone. It belongs to a family of immense formations, each one a record breaker in its own time, from the legendary Hercules, Corona Borealis Great Wall, a roughly 10 billion light-year expanse of galaxies, discovered through patterns in gamma-ray bursts, to the giant arc, a graceful curve of galaxies more than 3 billion light-years long. Together, these structures form what scientists now call the universe's megascale architecture, filaments, arcs, and walls woven into the visible edge of the cosmos. And yet, discoveries like Quipu complicate our understanding of cosmic order. Traditional cosmology holds that at scales larger than about 1 billion light-years, matter should appear evenly distributed, like faint mist. But these gigantic walls and arcs break that boundary, suggesting that gravity and dark matter might form more persistent patterns than once believed. In other words, the universe, while grandly expanding, may also still carry the fingerprints of its earliest clustering patterns, echoes of the first ripples of matter after the Big Bang. What's even more astonishing is how all of this connects back to us. Our Milky Way lies within one of the smaller components of this cosmic lattice, the Laniakea supercluster, about 520 million light-years wide. It's one strand within a much larger filament of the Pisces, Cetus supercluster complex, a billion light-year-long structure woven into the same web as the Quipu's galactic filaments. From our vantage point, we're like a single sparkle of light, strung between greater ropes of brilliance, part of a structure that spans the visible universe. If you zoom out far enough, the universe starts to resemble something alive, not chaotic or random, but patterned, even rhythmic. Galaxies act like neurons in a cosmic brain, connected by filaments of gravity that hum with faint whispers of energy. These filaments stretch, bend, and ripple through the voids, carrying the cosmic story written across billions of years. Quipul, like the ancient counting chords, is a ledger of the universe's memory, encoded not in knots of string but in light itself. And so, here we are, tiny conscious beings drifting on one small world inside one modest galaxy, gazing up and trying to fathom this endless architecture. The Milky Way may be ordinary in size when compared to titans like IC 1101, or to vast clusters like the Virgo and Hercules walls, but it holds something the others don't: awareness. Inside one of its spiral arms, a collection of atoms learn to look outward and wonder. That thought alone connects us to everything, to Quipul, to the glowing filaments, to the ancient light that left the first stars billions of years ago and still travels silently through the dark. Every photon that touches our eyes has crossed unimaginable distances to remind us of one simple truth. We are made of this universe, and the universe knows itself through us. As you imagine these colossal patterns, maybe let that idea settle gently, that in the grandest design ever known, you are not merely an observer, you are a participant in the story of light, gravity, and time. The universe isn't out there waiting to be understood. It's right here, stretching across your thoughts, looping through your imagination, the same way the galaxies loop through space, intertwined in a cosmic web that never truly ends. And so, as we drift deeper into the unimaginable vastness of the cosmos, we arrive at scales where the mind almost gives up trying to measure, where light itself becomes a way of painting time rather than distance. The galaxies, those glittering islands of stars, become mere specks within colossal networks, filaments of energy and matter stretching far beyond anything we can truly visualize. The newly discovered giant called Quipul, the cosmic cord of galaxies spanning 1.3 billion light-years, is both awe-inspiring and humbling. It's not just big, it's orderly, intricately laced like cosmic embroidery. Each filament in Quipul winds through clusters and superclusters, like threads tying together the heavens. When astronomers mapped it, they found a thread of light so long that it reshaped our sense of cosmic architecture. Its sheer size defies the very principle that space should be uniform on the largest scales. And yet, beyond Quipul lies even more. The King Ghidorah supercluster, for instance, discovered in 2022, spans roughly the same distance, about 1.3 billion light-years, and holds at least 15 galaxy clusters. Each one of these clusters teems with trillions of stars, and together they weave one of the densest regions of the known universe. It's like a massive fortress of gravity, surrounded by an ocean of voids, where the faintest galaxies cling to invisible threads of dark matter. Closer to our cosmic home, the Sloan Great Wall, discovered in 2003, once held the record at 1.1 billion light-years. Imagine a wall of galaxies so vast that if you could move at the speed of light, it would still take over 1 billion years just to travel from one side to the other. Every bright speck along that journey would be an entire galaxy, each of those galaxies holding hundreds of billions of suns. It's less a wall in the ordinary sense and more a wave, an oceanic swell of galaxies frozen in space. Then there's the South Pole Wall, mapped in 2020, located at the edge of our visible universe, enclosing a vast region of our cosmic neighborhood. It spans about 1.37 billion light-years and curves like a gentle arc across the southern sky. It's the closest of these megastructures to Earth, made of hundreds of thousands of galaxies linked together like a cosmic shoreline. It was discovered through measurements of galactic motion, by noting how their paths bend under gravity's invisible influence, revealing the hidden web connecting them all. These immense shapes, walls, arcs, rings and threads, are not static sculptures frozen in the void. They are alive with movement. Galaxies within them are slowly drifting, swirling around invisible masses, tied together by dark matter, the unseen glue of the cosmos that makes up about 85% of all matter in existence. Without it, these immense superstructures could never form, nor could they stay bound for billions of years. When viewed on the largest scale, the universe almost looks like a brain. Filaments act like cosmic neurons, connecting massive nodes that are galaxy clusters. Where those threads intersect, new galaxies form. Where they stretch thin, the voids expand. It's an elegant balance, everything connected, everything flowing, every part influencing the rest. Space is not empty, it's textured, patterned, exquisite. And yet, the paradox remains. The larger we zoom out, the more the universe seems to blur into simplicity again. Astronomers call this the cosmological horizon, where, statistically speaking, the universe begins to look the same in every direction, smooth and infinite. But that illusion of uniformity hides a fractal beauty. A universe of galaxies clustered into threads, threads woven into walls, and walls bending into loops that hint at patterns we still barely understand. Against this endless design, our Milky Way is a single point of light in one luminous strand. A small spiral galaxy spinning peacefully inside the Laniakea supercluster, part of the Pisces, Cetus supercluster complex, itself a single branch of this immeasurable cosmic network. Our galaxy moves through the universe at about 600 kilometers a second, carried along with everything else in this great current of creation. And as extraordinary as that may sound, perhaps the most profound truth is this. Out of all this immensity, one quiet corner of one spiral arm evolved consciousness. The same cosmic dust that makes up galaxies formed the atoms of our bodies. The same starlight that fills Quipu's clusters is the light that reflects in human eyes when they gaze upward and wonder. The universe builds awareness not apart from itself, but within itself. Every thought, every spark of curiosity is an echo of the universe awakening to its own existence. So, as you sit beneath the gentle arc of the Milky Way, surrounded by an ocean of galaxies, remember that you're more than a bystander. You too are part of this unfolding masterpiece, one thread of awareness woven into the infinite quipu of the cosmos. As we move even farther into the immeasurable vastness of the cosmos, the scale of what we're witnessing begins to dissolve into something poetic. The universe transforming from a collection of galaxies into an intricate living tapestry of light, space, and time. Each discovery adds another thread to this grand cosmic weave, showing that the universe's structure is far more exquisite and connected than anyone once imagined. The discovery of Quipu, the 1.3 billion light-year-long cosmic cord of galaxies, wasn't the end of such revelations, it was the beginning. Quipu stands like a luminous highway in the void, a piece of the universe's skeletal frame. But just recently, astronomers have revealed something equally magnificent, a structure stretching 1.4 billion light-years, composed of 68 galaxy clusters bound together by gravity and dark matter. Discovered by the Max Planck Institute using X-ray data from the ROSAT satellite, it now holds the title as the largest confirmed superstructure in the nearby universe. This formation is more than a collection of galaxies. It is a cosmic fortress of unimaginable density, a spine made of light and gravity. From end to end, it extends through space like a river made of galaxies, wrapping around regions of near-empty darkness called voids. Each cluster inside is a city of galaxies, each galaxy a swarm of suns, and every sun a potential host to worlds unseen. The mass of this entire structure is estimated to be around 240 quadrillion times the mass of our Sun, dominated almost entirely by the invisible hand of dark matter, the mysterious glue that silently shapes everything we see. When the light from these clusters reaches us, it carries not only distance but time. Much of the light began its journey when dinosaurs still walked the Earth. Each photon that arrives is a message from the ancient universe, a record of where those galaxies once were, traveling billions of years to enter our eyes. To map something like this is to trace time itself, every point of light a chapter in the story of an unfolding cosmos. And beyond these measured titans lie others. Stranger still, the giant GRB ring, for instance, spans nearly 5.6 billion light-years, a circle of gamma-ray bursts scattered through the night sky, like beads on a cosmic bracelet. The huge quasar group, LQG, stretches 4 billion light-years, made up of supermassive black holes lighting up the darkness like lanterns in a fog. The famed Hercules Corona Borealis, Great Wall, still looms mythically in our data, a structure nearly 10 billion light-years across, so vast that some scientists question whether it's even possible under current cosmological laws. Its existence presses against the limits of theory, standing like a whispered hint that the universe may not be as uniform as we once thought. Even closer to home lies the Holz-Ulana bubble, a gently rounded formation about 1 billion light-years across, containing around 56,000 galaxies drifting together in slow cosmic harmony. It's shaped like an enormous wave frozen in space, curving subtly through our section of the universe. These immense bubbles and arcs aren't random. They form along the invisible threads of dark matter that connect everything, forming a kind of three-dimensional map that reveals the universe as a colossal, interconnected web. At smaller scales within this web lies the Laniakea supercluster, home to our Milky Way. It stretches across 520 million light-years and flows gently towards something even greater. The Shapley concentration, one of the most massive known concentrations of galaxies in our local region. You can think of our Milky Way as a single leaf floating down one of the countless tributaries of this great cosmic river. If we step back far enough, our universe starts to look almost purposeful. The same patterns echo everywhere, galaxies clustering into filaments, filaments braiding into walls, and walls bending into rings and arcs. The cosmic web hums with symmetry and balance, its design neither chaotic nor rigid, but organic and ever-evolving. It isn't just matter shaping light, it's light revealing the music of geometry at the largest imaginable scale. Every one of these structures, the quipu, the great walls, the galaxy filaments and arcs, is a fossil of the earliest fluctuations that arose right after the Big Bang. Minute quantum ripples in that infant universe expanded over 13.8 billion years into the vast formations we map today. That means the same ripples that seeded galaxies also seeded you. The carbon, calcium, and oxygen in your body were once part of those same cosmic waves. So, when we ask, how does our galaxy compare to the largest structures in the universe? The answer, strangely enough, is that it doesn't need to, because every atom, every thought, every heartbeat is already a continuation of those structures. We are simply the universe at a smaller scale, learning to know itself in greater detail. As you let that idea settle, picture the entire cosmic tapestry, galaxies glittering like scattered diamonds, filaments twisting through the dark like threads in an infinite fabric. Our Milky Way, though modest compared to the titans of the deep universe, carries something no other structure has ever known: awareness. It is the small, luminous place from which the cosmos contemplates its own immensity. And that, perhaps, is its most extraordinary comparison of all. And when we step back once more, to the farthest edges of everything, the known universe reveals its grand design, patterns that blur the line between physics and poetry. These are not individual galaxies or clusters anymore, but entire cosmic walls, arcs, and threads that stretch across billions of light years, forming the skeleton of reality itself. The more we discover, the more it feels as though we are tracing the quiet handwriting of the universe. Among these structures, the Hercules Corona Borealis Great Wall, stretching a staggering 10 billion light-years, still stands as one of the most debated and mysterious formations ever found. Detected through the mapping of gamma-ray bursts, it challenges the very limits of physics and cosmology. It shouldn't exist, at least, not according to our understanding of how matter is supposed to distribute itself at the largest possible scales. If it's real, then it means the universe may be more interconnected and uneven than we ever imagined. Then there's the giant GRB ring, 5.6 billion light-years across, whose near-perfect circular symmetry has led scientists to wonder if it might be a ripple in space-time itself, a memory of cosmic events echoing across billions of years. The huge large quasar group, LQG, at 4 billion light-years wide, forms another of these impossible gatherings, where supermassive black holes in active galaxies blaze collectively, lighting up the universe like the embers of ancient fires. And somewhere behind them all, emplaced like an intricate knot in the pattern, lies the Quipu superstructure, the newly discovered cord of galaxies named after the Incan system of knotted threads once used to store memory. It stretches for 1.3 billion light-years, linking hundreds of galaxy clusters into a vast filament so immense that it surpasses every previous record in confirmed measurement. Each filament acts as a galactic highway, where gravity gathers everything from gas to stars, forming rivers of matter that stretch into the dark. Quipu's estimated mass, 200 quadrillion times that of our Sun, reminds us that matter, light, and time are endlessly entwined. Even nearer to us, the South Pole Wall, 1.37 billion light-years in length, bends across the southern sky, surrounding our own cosmic neighborhood like a hidden shoreline. It lies intertwined with the Sloan Great Wall, 1.38 billion light-years across, discovered 2 decades ago through the Sloan Digital Sky Survey. Together, they form part of an immense bridge of galaxies reaching into regions we still haven't mapped, regions where space curves and the structures begin to fade into the cosmic fog. Within this unimaginable complexity, our Milky Way still holds its quiet place. Inside the Laniakea supercluster, a gentle swirl spanning 520 million light-years, flowing toward the greater gravitational pull of the Shapley supercluster. These are like chapters within a novel of endless scale, each structure nested within one larger than itself, each connected by the same invisible substance, dark matter. It's the cosmic scaffolding that shapes everything yet reveals nothing of itself. It doesn't glow, it doesn't absorb or emit light, it simply bends space, guiding galaxies into formations more intricate than any human mind could design. Every layer we uncover, from stars to clusters to filaments, deepens the same realization. This universe is alive with order, not chaos. It is built upon harmony, woven with symmetry, expanding outward but never losing its coherence. These distant arcs, rings and walls aren't random at all. They are the grand aftershocks of creation, the frozen waves of the Big Bang stretched across time. And through it all, we remain part of the pattern. Every atom in your body was once part of the same web of matter, condensed from the same clouds that shaped galaxies and clusters. The light that shines between the stars is the same light that gives life to every heartbeat. When you look up, you are not small. You are the universe, condensed, conscious, and curious, awakening to its own reflection. So, as we end this journey of scale, from the elegant spiral arms of our Milky Way to the greatest structures ever conceived, let that thought linger. The same universe that stretches for billions of light years also lives quietly inside you. The atoms in your bloodstream were forged in stars that lie within this web. The curiosity in your mind is the same mathematics that holds galaxies in orbit. Somewhere between those truths lies the simplest and most beautiful answer to our question: how does our galaxy compare to the largest in the universe? It may be smaller in size, but not in significance, because without the Milky Way and without the observers it created, the universe could spin forever, vast, silent, and unaware of its own magnificence. It's through us, through thought, through awe, through wonder, that the cosmos finally looks back and recognizes itself. Imagine, for a moment, that everything we've explored so far, the Milky Way, gargantuan galaxies, like IC 1101, immense superclusters like Laniakea and Shapley, are merely the brushstrokes of something infinitely greater. If you could zoom out far enough, the universe would no longer look like scattered lights in darkness, but like a vast, interconnected web, cosmic threads crisscrossing through unimaginable distances, tying the past and present into one continuous structure. At this extreme scale, we encounter formations that dissolve our sense of proportion altogether. Structures such as Quipu, stretching 1.3 billion light-years, are no longer just gatherings of galaxies. They are whole chords of existence. They represent how the universe stores and remembers its own story. Every knot of Quipu is a cluster of galaxies, and every strand a filament of dark matter guiding them together through gravity's invisible hand. Further out, new discoveries continue to astonish. In February 2025, astronomers at the Max Planck Institute uncovered a colossal superstructure, roughly 1.4 billion light-years long, containing 68 massive galaxy clusters. It's the most detailed, confirmed structure of its kind, a map of matter connecting our local universe like an architectural frame. Its estimated mass exceeds 240 quadrillion suns, and its body is composed primarily of dark matter, that unseen substance shaping everything from cosmic webs to the galaxies themselves. Even though it's invisible, its presence bends light and binds the visible universe together. And yet none of these are isolated features. From the South Pole Wall to the Sloan Great Wall, from the Perseus, Pegasus filament to the Lynx, Ursa Major ribbon, all of these titanic structures link together to form the cosmic web, an endless map of filaments stretching across the observable cosmos. The spaces between them, known as cosmic voids, are vast stretches of nothingness, each one hundreds of millions of light-years across. Yet even the voids tell part of the story. They're the silent gaps between symphonies, the dark form that defines the light. When scientists observe this grand pattern through deep mapping, they notice something extraordinary. The structure of the universe mirrors the structure of the human brain. If you compare the distribution of galaxies and dark matter across the universe to the neural network of synapses and axons in the cortex, they look eerily alike. Both display self-organizing complexity, small nodes connecting into greater networks that balance efficiency with beauty. This isn't coincidence. It's the nature of complexity itself. It seems that the same laws that govern the growth of galaxies may govern the growth of thought. It's a humbling symmetry, consciousness within and cosmos without, both following the same quiet rules of connection. Perhaps that's why the universe feels strangely familiar when we contemplate it. The same mathematical and energetic rhythms that shaped galaxies also shaped us. We are, quite literally, the universe reproducing its own structure within itself. Now, as we turn our gaze back home to our Milky Way, it may appear modest by these vast cosmic standards, but our galaxy sits at a rare balance point. Large enough to be rich and dynamic, yet stable enough for billions of years of quiet evolution. It is a cradle that allowed awareness to arise. The vast giants like Quipu or the Hercules, Corona Borealis wall, are magnificent, but lifeless. silent titans drifting through eternity. The Milky Way may be smaller, but in its arms, life blooms, sunlight on oceans, thought within the mind. That may be the greatest wonder of all. The colossal webs and clusters beyond are the body of the universe, but consciousness, curiosity, the act of looking up, those are its voice. Through every observation, we complete a circuit in that cosmic brain. When we see the galaxies, it's the universe perceiving itself, billions of years after its own beginning. So when we ask how our galaxy compares to the largest in the universe, maybe the answer isn't about size or brightness. The giants exist without witness. But within the Milky Way, on one small world, awareness wakes up and whispers into the stillness of the stars. And that single whisper, the voice of understanding, may be the rarest phenomenon in all of cosmic history. The Quipu superstructure remains one of the most profound discoveries in all of cosmology, a revelation not only of scale but of meaning. As astronomers continue to analyze its geometry, composition, and gravitational effects, it's becoming clear that Quipu isn't merely another chapter in the story of our universe. It is the thread woven through many of its chapters, symbolizing connection, memory, and cosmic design. When it was first identified, Quipu already defied expectations. It spans approximately 1.3 to 1.4 billion light-years, containing 68 major galaxy clusters, billions of galaxies, and roughly 200 quadrillion solar masses worth of material, mostly dark matter. Some estimates suggest that within its domain lies 25% of all visible matter and 45% of all galaxy clusters in the nearby universe. It occupies about 13% of the local cosmic volume, effectively acting as one of the universe's foundational pillars. But beyond the numbers, Quipu is remarkable because it challenges how we think the universe builds itself. According to standard cosmological theory, every cosmic structure originates from small fluctuations that occurred just after the Big Bang. These variations in density gradually grew under the influence of gravity, pulling matter together over billions of years. Yet when astronomers modeled how long it should take for something this massive, this coherent to form, the numbers didn't add up. Even within the most advanced LFL-CDM, lambda cold dark matter simulations, structures as large as Quipu rarely occur. It's not just that its length of 1.4 billion light-years is immense, it's that it maintains distinct connectivity among its clusters. The galaxies are not randomly clumped. They are arranged like beads along gravitational threads, connected through subtle filaments of dark matter that tie them into an almost organic network. Under X-ray observation, Quipu appears like a glowing spinal cord, each galaxy cluster a node of heat and gravity radiating across millions of light-years. When the ROSAT data from the Classics project was first processed, the result was so striking that project scientist Hans Boehringer described it as visible to the human eye in the cluster density map. Quipu's main filament runs through a sweeping arc across the sky's southern hemisphere, with side filaments linking out to smaller galaxy groups. The patterns seem too intricate to be random. Astronomers compared it to the human nervous system, a cosmic one, stretching through time rather than tissue. And in a strange, poetic sense, the comparison feels apt. Quipu functions like the connective nerve of the cosmic web, the bridge where information in the form of light, matter, and gravity intertwines. As research deepened, scientists realized Quipu is not isolated. It is part of a family of superstructures, 5 major filaments that dominate the matter distribution between roughly 130 to 250 megaparsecs from Earth, about 425 to 815 million light-years away. Together, these 5 represent almost half of all galactic mass nearby. Quipu, however, is easily the largest, with its gravitational reach extending much farther, influencing cosmic flows and expansion patterns in measurable ways. One of the most spectacular consequences of Quipu's mass is its effect on cosmic motion. Galaxies outside its core appear to flow toward it over hundreds of millions of years. These bulk flows, known as streaming motions, are detectable in the slight deviations seen in local redshift data. In essence, Quipu acts like a gravitational anchor, pulling on a region of space larger than any structure ever confirmed. These effects extend all the way into the observations of the cosmic microwave background, CMB, bending ancient light faintly but measurably, a process known as the integrated Sachs-Wolf effect. By analyzing those subtle distortions in the CMB, scientists confirmed the fingerprint of Quipu itself echoing through 13.8 billion years of cosmic memory. That discovery has profound implications. It means that even the largest relics of the early universe still shape how we see and measure the cosmos today. And yet, perhaps the most dramatic truth about Quipu is that it is, cosmologically speaking, temporary. According to models of dark energy, the accelerating expansion of the universe will eventually overcome the gravitational bonds linking its clusters. In 1 trillion years, its filaments will have unraveled, stretching until its galaxies become isolated islands adrift in expanding space. What we now see as connections will dissipate into invisibility. This realization transforms Quipu from a record of grandeur into one of fragility. Its threads are living connections that will in time vanish from view. Future observers, if any exist, might look up and see none of it, their night skies devoid of the intricate networks we marvel at today. Our cosmic web is a fleeting masterpiece, a pattern fading even as we learn to understand it. To measure Quipu is to measure history. Every filament tells a story stretching back to the dawn of time. Its immense scale embodies cosmic memory, the record of how gravity sculpted complexity out of chaos. And when scientists named it after the Incan Quipu, they unknowingly revived an ancient metaphor, a form of writing not in ink or light, but in structure itself. The Incas used chords to encode stories, each knot representing value, lineage, or time. The universe uses galaxies. Every cluster, every filament, every ripple of light across space is one knot in a universal record, an archive written not by hand but by physics, gravity, and time. In that sense, Quipu may be the closest thing we have to the universe's autobiography. It threads together epochs, translating the invisible into the visible, the vast into the measurable. And in the same way humanity once tied chords to remember, the cosmos itself ties galaxies to preserve its own narrative. Our Milky Way is one tiny character in that cosmic manuscript, situated within the Laniakea supercluster. Our galaxy sits along a much smaller filament that itself feeds into larger structures, a tributary flowing into Quipu's ocean. The same gravitational forces that sculpt Quipu govern our home. The same unseen dark matter scaffolding that holds its clusters also holds our solar system in its gentle, inescapable grasp. When we peer into Quipu, we're not gazing into a distant foreign object. We're looking into our own reflection at cosmic scale. Just as the Milky Way contains billions of stars forming arms, rings, and spirals, Quipu contains billions of galaxies forming arms, knots, and patterns of its own. They mirror each other, microcosm to macrocosm, each bound by the same universal laws. And here, in one small system within one small arm of one average spiral galaxy, those same laws gave rise to something extraordinary: awareness. The atoms within us were once dust in dying stars, and those stars were once part of galactic clusters bound by gravity's hand. Across billions of years, those same processes birthed Quipu, and also birthed us, capable of seeing it, understanding it, and describing it. We too are made of Quipu. The carbon in our skin was woven in supernova billions of years ago. The calcium in our bones forged in the hearts of ancient suns. The hydrogen in our breath was born in the Big Bang itself, the same primordial material that now glows faintly along Quipal's unfathomable filaments. Our connection to it is not poetic invention, it is literal chemistry. Its physics become life, matter become mind. So when astronomers trace Quipal's filaments, they are not just mapping the universe, they are reading our ancestry. Each layer of starlight, every ripple of dark matter, is a record of who we are and where we came from. Somewhere in one of its countless galaxies, another world may be looking upward too, wondering what lies beyond their sky. Perhaps they too have discovered the Quipu, recognizing the same cosmic handwriting stretched across their corner of space. Across billions of light years, separate civilizations could share this quiet realization, not that they are small, but that they are part of everything. And as the universe slowly expands toward cold eternity, Quipu will remain, for a while, as a bridge between beginnings and endings. In time, its threads will dissolve, its light will scatter beyond reach, and the cosmos will fall silent again. But before that finale, there exists this incredible moment right now when life can look up, understand and marvel at its place in the cosmic text. If there's poetry in the universe, this is it. A 1.4 billion light-year filament of galaxies, spanning dark space discovered by beings made from the same particles it connects. The beauty lies not only in the structure, but in the observer, the mind that can behold the vast and the infinite, and still find meaning within it. Our Milky Way may be small, but through it, the universe has found its voice. Through the eyes of one species on one planet circling one star, the cosmos whispers its own name, Quipu, the reminder of connection, pattern, and memory across eternity. And so the story comes full circle from one humble galaxy adrift in a sea of light to the recognition of a structure that ties all galaxies together. It is a story of scale, yes, but also of belonging. The universe stretches endlessly outward, yet through knowledge, imagination, and wonder, we reach back and touch its edge. If you listen closely, beyond the echo of stars, beyond the silence of the void, there sips a quiet truth humming in the darkness. The universe is vast, but not beyond understanding, and not beyond beauty. Because somehow, impossibly, within its endless web of stars, it made room for us.